Now let us see another question, okay, again, which involves the square of the magnitude. Prove that. Okay, the left hand side is this: a bar plus b bar square plus c bar square plus a plus b plus c square. Okay, and the right hand side is b plus c holding square plus c plus a holding square plus a plus b holding square. Okay, so we want to prove that this left hand side is equal to the right hand side. Okay, solution. Okay, let us start with the left hand side first. Okay, the left hand side, magnitude a bar square. Okay, maybe let us leave it as it is. Okay, or maybe we can even, okay, let us leave it as it is. Okay, but this one, it looks very complicated, but always remember, because it is a square, we can turn it into a dot product. In fact, we can even turn this one into a dot product. Okay, but let us just leave it as it is first. Okay, so you'll be having dot a plus b plus c. Okay, this one will remain as it is. Now just expand this one. You will be having a dot a, which is, okay, I will write it down, plus a dot b plus a dot c. Similarly, plus b dot a plus b dot b plus b dot c plus c dot a plus c dot b plus c dot c. Okay, so this is what we are having, a square. This will always remain as it is. Okay, a dot a will give you a square. A dot b, just say a dot b, and b dot a, you can write it as 2 times a dot b, because we can interchange the order because it is a scalar product. A dot c, and similarly we are having over here c dot a, so ultimately we will be having 2 times a dot c, and then we are having this b dot b, so plus b square, b dot c, c dot b, we will be having 2 times b dot c, and this one will give you plus magnitude c square. So just simplify it again. So a square, and this one will be having 2 times a square plus, okay, just simplify it, you will be having something that looks like this: 2 times a dot b, 2 times a dot c, and 2 times b dot c. So this is what we are having after simplifying the left hand side. Okay, now let us, okay, it looks very complicated to proceed from here and try to get the right hand side. So what I will do is, I will leave this one as it is. Okay, maybe I will name it as equation 1. Okay, the left hand side is equal to this, which is equation 1. So now I will proceed from the right hand side. I will see whether I get the same thing or not. Okay, now we proceed from the right hand side. Right hand side is b plus c holding square plus c plus a holding square plus magnitude of a plus b holding square. Okay, so this one we can use that formula, turn it into a dot product, b plus c dot b plus c. Similarly, this one we can turn it into a dot product, dot c plus a plus a plus b dot a plus b. So this is what we will be having. So now just expand it. B dot b will give you b square. Okay, we will be having something that looks like this in a similar way, like what we did in the left hand side. Expand this one, c dot c, c dot a dot c, a dot a. We will be having something that looks like this, 2 times a dot c plus a square. And similarly expand this one, you will be having a square plus 2 times a dot b plus magnitude b square. So you can see that ultimately it becomes the same thing as the left hand side. So this is what we are having, okay, and then you can conclude that the left hand side is equal to the right hand side, which is what we want to prove. So again, it looks very complicated, the question, but if you turn it into a dot product, it will become much more simpler. Next, okay, if you remember, okay, there are still some more exercises, okay, but before doing those exercises, I will try to prove what we did not prove in the last video. That is, we will try to prove this one today. We will try to show that a dot b plus c equal a dot b plus a dot c. Okay, prove that. Okay, so what we are going to discuss now is a proof for this one. We don't have any idea right now how to do this one, but we will need a new idea. Okay, and that idea is something about the projection of a vector on another vector. Vector on another vector. Again, this is something that you had already learned in your higher secondary. So let us see. Projection of A on B. Okay, let us try to project vector A on B, or you can even project B on A, doesn't matter. Okay, maybe let us project B on A. Again, these are just symbols, you can easily interchange. Okay, you can interchange the diagram which I will draw. Okay, so B and A, they are vectors, so there will be some angle in between them. Okay, so this one is a vector B and this one is a vector A. So what we will do is, if you are thinking about the projection of B on A, is just imagine a light source coming from this direction. Okay, if you are imagining something like this, okay, light source is coming like this, so this B, it will cast a shadow. Okay, if you draw the shadow, this one will be the shadow of B. Okay, the shadow of B on A, it is this portion. Okay, by a projection, we mean the length of this shadow. How much is the length of this shadow? Okay, so if this angle is theta, okay, maybe I will write it down. Okay, maybe A, B, okay, C. Okay, just remember that A, it is this whole vector. Alright, whereas the projection is just AC. Projection of B on A, it is this shadow AC. Okay, AC you can write it as magnitude B cos theta. Right? If this angle is theta, then cos theta will be how much? Cos theta will be AC by AB, right? AC by AB. AB, it is magnitude of this vector B. Okay, so this is what we are having. Okay, it is B cos theta, but remember that cos theta, how much is A dot B? A dot B is magnitude A, magnitude B, cos theta. So cos theta will be A dot B divided by magnitude A, magnitude B. So it will be something like this: magnitude A, magnitude B. So how much will we get? We will get A dot B divided by mod A. So this is the projection. Alright, I hope it is clear. Alright, so whenever you are asked to find the projection of one vector on another, you can either use this formula, which is B cos theta, or you can even use A dot B divided by A, the magnitude of A. So what we will do now is we will try to prove this one by using the idea of projection. Why exactly do we need to use projections over here? Okay, it will become clear once we do the proof. Okay, let's see. Proof. Always remember that vectors, they can be moved, okay, so that they can have the same initial point, or you can move them anywhere that you like, as long as you move them parallel to one another. Okay, so let us say, okay, so A, B, and C, they are given vectors. So we can always draw a figure, something that looks like this. Okay, A, we will keep it on the ground. B and C, B, we will move it in this way. Alright, so it will be somewhere above. And C, we will draw it in this way. Okay. Alright, so we will draw something like this. Okay, even. Okay, you can draw another way. Okay, but for now, okay, let us draw it like this. Okay, A, the length of A doesn't matter. It can be long or it can be short. Okay, but we will use projections anyways. So this vector is B, this one is C. Okay, now join the endpoints. If you join this endpoint, how much will it be? By the triangle law. Okay, maybe I will use this one. See, by the triangle law, AB plus BC will give you AC. So this vector will be B plus C. Okay, by the triangle law. Okay, so the proof starts something like this. Let B bar equal AB, C bar equal BC by the triangle law. By the triangle law, we will be having AC bar equal B plus C. Okay, so what do we need? Okay, we will need A dot B plus C. In the left hand side, we will need this. And on the right hand side, we will need A dot B plus A dot C. Okay, so now comes the idea of projection. Okay, if you notice, okay, just drop this shadow. Just drop the shadow of AB over here. Okay, let us name this one as LM. LM is the shadow of AB, or we can say that LM is the projection of B on the vector A. Similarly, BC is the projection of BC. It is MN. It is the projection of C on the vector A. We have. Okay, sorry about the dogs. We have LM equal projection of B on A. Okay, projection of B on A. If you remember, we have got formula, which is A dot B divided by magnitude A. Similarly, what did we have? Mn will be the projection of C on A. So the projection of C on A will be A dot C divided by magnitude A. Okay, so now we have got AB and AC. Okay, whereas AC, Ln as a whole, it will be the projection of B plus C on A. Also, Ln equal projection of B plus C on A. Again, if you use that result, what will we be having? We will be having A dot B plus C divided by magnitude A. Okay, so this is what we will be having from this figure. But if you see, we can write Ln, we can write it as Lm plus Mn. But okay, so the proof continues over here, but Ln equal Lm plus Mn. So substitute Ln from this equation, we will be having A dot B plus C by magnitude A is equal to Lm, which is A dot B by magnitude A, plus A dot C by magnitude A. So this magnitude, because it is a scalar, we can multiply throughout by it. So ultimately we will be having what we want to prove.